Welcome. Today we're going to learn how to add and subtract numbers written in scientific notation. I'm going to start out with two numbers written in scientific notation that are very easy to add. Now, by all means, there's nothing wrong with you converting them back to standard form and then adding them and then converting them back to scientific. In other words, you could take that 3.4 times 10 to the third, which just means I'm going to move the decimal 3 places. So there's once past the 4, 2, 3. So in other words, it's 3,400 is this first number. Again, converting this one to standard notation, I'm going to move it 3 places. That's going to be 2,500. Then you add like normal 0, 0, 9, 5. Then you got to convert back to scientific notation by moving the decimal 3 places to the right, which makes it 5.9 times 10 to the third. And by the way, what I like to remember is if I'm taking this number and making it smaller, the exponent on the 10 must get larger and vice versa. And we're going to talk more about that in a minute. But hopefully you noticed it might just have been easier just to take these two numbers and realize that I'm going to, as long as the exponents are the same, I can just add these two numbers together. The 3.4 to the 2.5. So 0.4 and 0.5 gives us 0.9. The 3 and the 2 add to give us 5, which is 5.9. Now here's the important part, times 10 to the third. We keep the exponent the same when we're adding. Don't accidentally add the exponents. We're not doing times between these two tens. We're just adding them. It's like we're adding 3.4 of these to 2.5 more of those, so we get a total of 5.9 of those 10 to the thirds. So as long as the exponents are the same, we can add them. Now, what happens if the exponents are not the same? And what happens if they're larger and it's harder to write them in standard note form? You still could write those in standard form. By all means, you can write them out and then add them and then go back. But what I would like to do is help us realize that we can actually adjust one of them to get it to be the same as the other one. Normally what I like to do is I like to make the smaller one match the larger one if the exponents are positive. So what I'm going to do is I'm going to leave that first number alone, 5.8 times 10 to the 7th, minus. Now what I'm going to do is I'm going to increase this power of 10 by 1. I'm going to make it a 10 to the 7th. But if I increase this by a power of 10, in order to keep it the same number, because I really don't want to multiply by 1 more 10, otherwise it's a larger number, what I need to do is make this smaller by a factor of 10. So if I increase this exponent, I must decrease or make this smaller by moving the decimal over 1. So I'm going to make it 0.26. Now the exponents are the same, I can add like normal. I can take that 5.8, add it to the 0.26, making sure I watch my decimal place, right? 0 and 6 is 6, 8 plus 2 is 10, carry the 1, 6.06. So I know when I add those two together, I get 6.06 times, and again, we keep the exponent the same when we have that same exponent on both. Now, if perchance you got to a number here that wasn't a number smaller than 10 but larger than 1, you would have to adjust the decimal point, kind of like I adjusted it here. Let's do one more because it will probably happen on this one, and you'll see what I mean by that. Now here we have negative exponents, and again, the negative exponents are so large it would be hard to write these out in standard form and then add them. By the way, if you noticed up here, I made a mistake because this was subtraction, not addition. I really should have subtracted. I should have borrowed from the 8, made that a 7. 10 minus 6 is 4. 7 minus 2 is 5. And 5 minus 0 is 5. That really should have been 5.54 times 10 to the 7th, not 6. I didn't add them, I subtracted them. I caught my mistake. Always be watching or thinking about mistakes. This one is addition. And that's why when I got to this one and I looked and I saw that addition, I thought, wait a minute, one above was an addition, but I added. So that helped me catch the mistake I made before. But now let's try to adjust this one very quickly so it has the same exponent as this one. So I'm going to go 8.34 times 10 to the negative 14. So I didn't change this one, but I am going to change this one to be a 10 to the negative 14. Now I need to be very clear and precise here. Hopefully you're listening. Negative 14. I actually made this smaller. Negative 14 is smaller than negative 13. Since I made it smaller, I have to make this larger to balance. If you make the exponent on the 10 smaller, this needs to get larger. I'm going to move this decimal 1 to the right. So I'm going to be 68.9 times 10 to the negative 14th. Now I have the same exponent. I can have that 10 to the negative 14th, and I can actually add those two, the 8.34 to the 68.9. Again, watching your decimal placement, that's going to be a 4. 9 and 3 is 12, carries the 1. 8 and 8, 16 is 17. So it's 77.24. 77.24 times 10 to the negative 14th. Now, this is not scientific notation. This decimal's in the wrong spot. So what I need to do is I need to move the decimal over. I'm going to make this part out front smaller, 7.724, because I moved the decimal 1 to the left. If I make this smaller, I have to make this larger, which means larger is closer to 0 on the number line, or actually, I mean to the right on the number line, which is closer to 0 when you're dealing with negative numbers. It's going to be negative 13. And that would be our correct number. That's why up here on this one, I said I like to make the smaller one larger. I didn't do that down here. I actually made the larger one smaller, because when it comes to negative numbers, if you move to the left on the number line, it's actually smaller. It would have been better to make this a negative 13, which is actually larger, and made this one smaller. So in other words, it would have been better to do 0.834 times 10 to the negative 13, which is a larger negative number than the negative 14, not change that second one, 6.89 times 10 to the negative 13. Now I have the same exponent, and the decimals are going to be right. So when I add the 6.89 to the 0.834, I'm going to get the 4, the 12, 16, 17, 7.724 times 10 to the negative 13. So now the decimal place is in the right spot. So you always try to make the smaller one equivalent to the larger one. The smaller one equivalent to the larger one. If you have questions, please bring them to class.